right, on today's episode of Python Papi, we're back inside our smart contracts project. Let's have a look at what we're going to be going over today. And today we're back inside of our Web3Py favorites module, and we're still in deploy the contract to an EVM section of the module. So today we're going to dive right back in to a new portion of that section, and we're actually going to be doing some light reading. And tomorrow we'll be back inside of the contract, so I can show you exactly what we're going to be doing. So in this section, we will go over the process of signing the transaction. Now that we created our transaction object, which is going to include the code for our Viper contract, we need to sign the transaction before we can send it to the EVM. We're going to send it to the zero address, which is the address that is used to deploy the contracts to the EVM. The zero address is a special address that is used to indicate that the transaction is a correct deploy, that is a contract deployment transaction, and then it is not an address that is used to send transactions to existing contracts. So signing the transaction is a process that involves using our private key to create a digital signature that proves that we are the owner of the contract or the owner of the account that is sending the transaction. This is done to ensure that the transaction is valid and can be processed by the EVM. We will be using a Web3 tooling to sign the transaction, and we'll be using the sign transaction method of the Web3.Py library to sign the transactions. The sign transaction method takes the transaction object as an argument. It returns a signed transaction object that can be sent to the EMV. Now, this is how we implement that into our code. You see, you have signed transaction equals w3.eth.account.signed transaction. It's going to take the transaction as a parameter. Here, our transaction variable is the transaction object that we created earlier, and the signed transaction variable is the signed transaction object that we will use to send a transaction to the EVM. Just for an example, we will hard code our private key into the code, but in the real world application, we would want to use a secure method to store or retrieve our private key, such as using hardware wallet or secure key management service, or we can use an .env file to store our private key. And we're going to go into more of that. Like I said yesterday, I showed you the private key was commented out. That's because when we initially started, we were actually building it to show our private key, not show it. It was still secure in a way, but we just wanted to hard code into our code so we can see what it looks like. But moving forward, we would never ever do that. But of course, we'll go over more topics like that in deep as we move forward, and I will keep you posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.